Hi, I am Mrs. Sloan, and this is part of the series on the purpose and the practice behind the AP Biology equations and formula sheets. These are the formulas you're going to need to know in order to be successful on your AP Bio exam. So there are several of them, and today I'm going to do Simpson's diversity index. So by purpose is how does this tie to the curriculum? Why is this equation important for you to know? And then I'll give you some practice on how to do it, all right? So let's get going. So to understand the purpose behind Simpson's diversity index, you need to understand that there is value in biodiversity. Now, when you learn about biodiversity, you'll learn about genetic, community, and landscape biodiversity. Genetic means within a single population that there is variety in the genes. Community means that you have several different community interactions, different populations interacting with each other. And then landscape biodiversity is just mountains, streams, lakes, there's diversity there. Now, why do you want to have this type of biodiversity? Well, there's direct and indirect value. Direct value might be something like medicinal, that we want to maintain the biodiversity, let's say in a jungle, because there might be a plant there that's going to provide a medicine for us. Indirect value might be like, it's beautiful to visit the jungle. So that's harder to quantify, right? But there is some indirect value in that. What this equation does is it measures the biodiversity, the number of different species. And the way it does that is it gives you a percentage, an odds, just like in genetics when we had odds, that if you reach into this community, what are the odds that what you reach in and pull out are going to be two different species? So if you had only a 10% chance of getting two different species, and that's a pretty narrow range, and probably there's not a lot of biodiversity. But if you had a 90% chance of reaching in and getting two different species, then that must have a lot of biodiversity. So the formula that you use, let me get on the right page here with you. The formula that you use is Simpson's diversity index. And what that is you're taking 1 minus, and this right here, that kind of funky E means sum, and that's in several of your equations. The sum of, and you take each species and divide it by the total number of species that you have, and you square that, and you add them all up. I'll show you that in just a second. I'll show you how to do that, right? And remember, what it's measuring is the probability that two individuals randomly selected from a sample will belong to different species, right? And the higher the index, the higher the number that our diversity index is, the greater the biodiversity. So let's take a very simple community. And so I've just listed 4 species, all right? So let me do it with you. I'll start you out, okay? So when you look at this, you go, okay, let me see first, I need to solve for N, which is the total number of all the organisms that you have in that community. And that'd be really hard to measure if you're like in a jungle, right? So this is just a simplification. So I would say, okay, here I have 5 anteaters, 100 beetles, 10 monkeys, and 2 sloths. That is a total number of species that I have in this community of 117. So N equals 117. Then I just need to deal with each one of these. So I'm going to start with the anteaters. So I'm going to say, so the diversity index equals to 1 minus sum of, is I'm going to do each one of them. So I'm going to start with the anteaters. I have 5 anteaters. So that's this little n right here. I have 5 anteaters over a total of 117 total species. And I'm going to square that. And then I'm going to add that up, and I'm going to do all of this together. And I'm going to have 100 beetles over a total of 117 total species. And I will do that for each one of those. I'll do that for the monkeys. I'll just do it for you so you see. Okay, and I would do that for the sloths. Okay. I would do it for each one of those. I would add this, I would get a total number here, and I would subtract that away from 1. So here I've done the math for you here on the next frame. So you can see it. If you need to, pause just for a second and kind of look through it and see if that makes sense to you. So when I did that, here's the math already done. Okay, I had these 4 different numbers. I added those up, and that added up to 0.739. I subtracted that from 1, and I got 0.261. That means there's a 26% chance for this particular community of anteaters, beetles, monkeys, and sloths. There was only a 26% chance when I reach in and grab 2 species that they will be different from each other. Now, if I had more species, it would obviously increase the odds from 26% on up. Now, let's go the other direction so you can see patterns. So if they ask you about a pattern, like what would you expect? For instance, if we only had one species, let's say we didn't have anything other than the beetles, right? We didn't have any monkeys, no sloths, no anteaters. What do you think's what's gonna happen to this number? Okay, is that number going to go up or is that number going to go down? Well, if we redid it, so we said diversity index equals 1 minus, I only have 1, so I don't even have to sum anything up here. I have 100 beetles, right, over a total species of 100 squared. Well, 100 over 100 is 1, and 1 squared is 1. What is 1 minus 1? Right? Because this is going to be 1. It's going to be 0. There's a 0% chance. If I only have one species, there's a 0% chance that I would grab 2 different species, right? So as you increase the numbers of different species, you're going to increase that diversity index, which is measuring biodiversity for a community. All right? I hope that is helpful. If you're one of my students, I will see you in class.